Okay, guys, we're on to section 1.3, complex numbers. So before we get started, just to kind of get some motivation for this, I want you to consider an equation like this, okay? Now, if you remember from your algebra, there's a few different ways of solving this, but one fairly common way is to do this, is to go ahead and actually take the square root of both sides, right? Because if you remember, the square root of something squared is just the something. So say the x in this case. But there's one very important thing we had to remember when we do this, and that was to put this plus or minus. Hopefully that looks familiar from algebra. That would leave us with x equals plus or minus 2. And if you think about it, this makes sense, because if I take 2 and I plug it into the original equation, 2 squared is 4. And if I take negative 2 and square it, it'll also be 4, right? Negative 2 times negative 2 is also 4. That's why we got to put the plus or minus whenever we do a square root or a fourth root or any even root. It takes into account that extra possible case of it being negative. Okay, so hopefully that's not too bad. Now, what about if I had x squared equal to negative 1? Well, I guess we could try a very similar thing. We could say, okay, well, let's take the square root of both sides, right? It's the same sort of idea, but we kind of run into a hiccup, and that is this. Question is, what is the square root of negative 1? If you have your TI-84 plus, go ahead, try plugging it in, okay? So what you should get is that it's a non-real answer. There is no real number. There isn't two numbers that when multiplied give you negative 1, or at least not two real numbers. So what are we going to do? This is where imaginary numbers come in. And you're saying, okay, why are we using imaginary numbers? They're to help us solve certain equations we can't solve right now. But the good news is we can convert them back to real numbers. Okay? So that's where we introduce the imaginary unit. Okay? That's what we're going to call I right here. This is the imaginary unit, I. Okay, we're going to define it to be equal to the square root of negative 1. If that's true, if you were to square both sides then, okay, I squared would then be negative 1, right? Because a square root, when you square it, the square and the square root, they sort of, you can kind of say they cancel each other, okay? So that's cool because if I square the imaginary unit, then I'm back to a real number, actually, okay? So here's the idea behind the complex numbers, okay? Let A and B be real numbers, okay? The form of a complex number is A plus BI. Now, in this A, we call the real part of the complex number, okay? And B, we're going to call the imaginary part. Okay, so it's got two parts, a real part and an imaginary part. Well, what does this mean? What does that tell us? Well, it tells us that all of these real numbers that you've been using all through your algebra, all through math growing up, these real numbers are actually technically also complex numbers, just with zero imaginary parts. Likewise, you could have a number such as I that has only imaginary parts and no real parts. So essentially what we did is we took the scope of numbers and we just expanded it. We're expanding our horizons. You can think of it that way, okay? So I just want to show you a few examples. Here's some imaginary numbers. 2 plus 7i has a real part of 2 and an imaginary part of 7. Notice that it's in this sort of standard form right here, a plus bi. 3 minus 2/3 I, same idea. As long as this is a real number right here, that's fine. I could even have square root of 2 right there. Down here, negative 4i. Well, this is the same as 0 minus 4i. So this is also a complex number just with a 0 imaginary part. And what about the number 5? Well, this number 5 that we've been using all these years is also complex. It's the same as 5 plus 0i. It's just a complex number with a 0 imaginary part. Okay, with no imaginary part, I guess we could say that. Okay? So this is the idea behind complex numbers, why we use them, because then we can start solving equations like this. Okay, and we'll get to that. All right, so continuing on. Before we can move on, you have to remember some rules from your algebra. If you remember, if you take the square root of two numbers that are being multiplied, you can split these up into separate square roots. So what I mean by that is if I have the square root of, let's say, 9 times 4, okay? Well, we know that that is the square root of 36, which is 6. And really, it's plus or minus 6, but usually we just use the positive part, right? But we could say, well, this is the square root of 9 times the square root of 4. The square root of 9 is 3. The square root of 4 is 2. And we can still arrive at that answer of 6. Okay? So that was one of our rules from algebra. Also, the same thing works with division. If you have the square root of a quotient, you can have the square root of the quotient of each square root. Same sort of idea. From that, this is what we're going to do. We're going to say if a is greater than 0, so we have a positive number, then if we have the square root of negative a, okay? So why do we say if a is greater than 0? Well, if it was less than 0, then this would just be positive and we'd just take a square root. Since it's not, though, the square root of negative a can be broken down into the square root of negative 1 times a. Then we can use this property up here, and then we can say this is I times the square root of a, right? Because we know square root of negative 1 is that imaginary unit. Okay, so that's going to be the idea as we get used to these. We want to keep that in mind, is that I is the square root of negative 1, and we don't want to forget that I squared is negative 1. Because whenever we have an I squared, we want to convert it back to a real number whenever possible. So, first example, simplify each expression. So here's an expression. We have square root of negative 16. Now, if you looked at this before you knew about imaginary numbers, then you might say, well, I can't really do anything with that. But now we can. So I'm going to use this idea that we just had up here down here. So I'm going to start by saying, okay, well, this is the square root of negative 1 times 16. Okay, so the first thing I'm doing, I'm going to filter out that negative part. That is going to be the square root of negative 1 times the square root of 16, just using that above rule we have up here. Okay. Now, we know that the square root of negative 1 is I. So this is just going to be I times the square root of 16. Well, that's I times 4. So I'll just say that that's 4i. Nice and simple. Same idea here. Square root of negative 48. Well, that's the square root of negative 1 times the square root of 48. Now notice, I did skip this step. As you do these, you can go a little bit quicker. So hopefully you're fine with that. So this is going to be I square root of 48. But the square root of 48, let's think about this for a sec. Can we break that down more? Can we simplify that more? What does it mean to simplify that? Well, if you remember, with a square root, we want to try to pull out perfect squares. So hopefully this looks familiar to you. We could say this is I times the square root of 16 times the square root of 3. So I'm just saying that the square root of 48 is the same thing as the square root of 16 times 3. Okay? And usually when I do that, I look for the biggest perfect square. So perfect square, I mean 1, 4, 9, 16, 25, things we know the square root of. Well, why did I do that? Well, now this is I times 4 times the square root of 3. So this is 4i square root of 3, or usually the way I write is 4 square roots of 3i. Okay? In fact, I prefer that one. Okay? Now, you could have just as easily broken it up this way. I times the square root of, maybe you didn't notice the 16, and you say, oh, well, I know 4 works. And that would be times the square root of 12. It just takes a little bit longer. This would be 2i root 12. Then we'd say, okay, well, that's going to be 2i root 4 root 3. 2 times square root of 4 is 4i root 3. You come to the same conclusion. It's just a little quicker when you can pull out the bigger ones. Okay? Finally, square root of negative 24 is going to be the same idea. Square root of negative 1 times the square root of 24. That's going to be I root, I see 4 and 6. 4 is a perfect square, so this is 2 root 6i. And I can't pull any perfect squares out of the root 6, so I'm all done there. Okay? And that does it for this first video.